There are many times when we look at a surface that we'd like to understand the peak height, but perhaps there's a bit of noise or dirt or debris on the surface, and at the same time, maybe we're interested in the valley depth of a surface, but there might be a pit or an odd scratch that isn't really part of the surface we care about. For these cases, it's useful to look at an average peak to valley, or an average peak or an average valley, rather than the extremes. Now, we talked about this approach in the RZ parameter in another video. If you haven't seen that one, go check that out, because we're going to use the same principle here to determine an average peak height or an average valley depth. So like RZ, we're going to break the surface into sampling lengths, and a sampling length would be a filter cutoff wavelength in the case of roughness, for example 0.8 millimeters, and in the case of waviness or primary, we may just simply break the profile into 5 sampling lengths. Whatever length of evaluation data we have available, that evaluation length is broken into 5 samples. But for the case of roughness, we're going to use the filter cutoff wavelength, and in each sampling length, we'll determine an average peak height based on the highest peak in each one. So each sampling length has a highest peak, and we will look at the highest peak from each of those sampling lengths and come up with an average. The average of all of these individual heights relative to the mean line will become our average peak height. Some of these are very low peaks and some may be high due to something like dirt, and they're going to come up with some average. Now, this average has different names in different standards. The ISO standards base all of their parameters on a sampling length. So the RA parameter is based on the RA and a sampling length, and then we average together our other RA values. So in this case, RP, the roughness profile peak height, is this height for this sampling length, RP is this height for this sampling length, and the average RP becomes the total RP for the evaluation length. So RP, according to ISO, is the average. Now, in the American standards, the entire evaluation length is treated as the parameter calculation. So RP in the American standard would look for the highest peak, ASME, as RP. Since the evaluation length is the region or length of interest, RP according to the American standards would be here, and this parameter down here, this average, the average in the American standards would be RP, and we use the designation M for mean, or the statistical term for average. So RPM, according to the American standard, is this average. RP, according to ISO, is the average. Similarly, we can look at the valleys and look at the deepest valley in each sampling length and average those together. And the average depth of those valleys would be RV according to ISO, or RVM according to ASME.